On behalf of the USDA Natural Resources Conservation Service, the Georgia Soil and Water Conservation Commission, the Upper Chattahoochee River Soil and Water Conservation District, and Schnabel Engineering, we thank you for your interest and participation in this third public meeting for the Settingdown Creek Dam Number 6 Supplemental Watershed Plan and Environmental Assessment. The purpose of the planning study is to assess the Settingdown Creek 6 watershed, evaluate the performance of the existing watershed structure, develop a plan to address compliance issues, determine if federal financial assistance will be available to address those compliance issues, and to determine if the project sponsors would like to continue operation of the dam within the NRCS watershed program. As part of the planning study, public participation is of great importance. The objective of the public participation plan is to inform the public and watershed stakeholders of the planning effort. A series of public meetings have been held for Settingdown 6. The first and second public meetings included a brief history of the NRCS watershed program, a brief history of dam safety, considerations for dam design, operation, and maintenance, an overview of the Settingdown Creek watershed and the specific dams that have been included in the planning study, and also an opportunity for the public and other stakeholders to submit questions and comments regarding scoping topics and the identification of project opportunities and concerns. The second public meeting included a list of potential rehabilitation alternatives for the dam. The first public meeting was posted to Schnabel's YouTube channel from August 7th to August 17th, 2020, and the second public meeting was posted to Schnabel's YouTube channel from December 18th, 2020 until January 4th, 2021. Please note that the first and second public meeting presentations for Settingdown 6 have been reposted to Schnabel's YouTube channel for those who were unable to view the presentations during the allotted date ranges listed above, in the event that they would like to review those presentations with this third presentation. After the second public meeting, a series of comments were received. We'll take this time during this presentation to present those comments that were received. Comment 1. In the 3 years I have lived adjacent to Settingdown Creek Dam Number 6, the water levels between low and high have varied by more than 8 feet. At least 2 times per year, the water level is within 12 inches of the top of the riser structure, most recently after the September 2020 hurricane. To decommission the dam would put considerable water downstream, flooding numerous homes on the west side of Hopewell Road, as well as create significant sedimentation that the current structure contains. Comment 2. Settingdown Creek Dam Number 6 is home to fish, egret, herons, ducks, geese, and a multitude of additional aquatic wildlife. It is also adjacent to wetlands that further protect the wildlife from human intrusion. Dam decommissioning would eliminate this wildlife, in addition to causing flooding across Settingdown Creek Road. Comment 3. The no action option is the least expensive and least wildlife intrusive option. The existing dam structure is functioning properly for flood control and sedimentation collection. The dam decommission option creates more flooding and sedimentation issues downstream while having the greatest impact on wildlife. It may solve 500-year flood concerns with the dam, but creates new issues that would require home destruction and removal to remediate human flood threat downstream caused by the dam removal. Dam decommissioning negatively affects both wildlife and humans and should not be considered an option. Both of the spillway options are possible, but would take years to accomplish and be expensive. As a landowner of a portion of the lake, I would ask that the property owners be considered for the reduction of their home/land values in any option chosen. The third public meeting presentation will discuss the following topics. A review of the Settingdown Creek watershed and the specific dams that are included in the planning study. A review of the existing conditions associated with Settingdown 6, and the presentation of the shortlisted alternatives to address concerns with the dam. These will include a no action alternative, which would be a future without federal investment alternative, meaning that the project sponsor would be responsible for funds to address concerns or issues with the dam. There would be no federal funding with that option. A future with federal investment alternative will be discussed, as well as a decommissioning option that is required as part of the planning process to be considered. The locally preferred alternative, based on conversations with the project sponsors and NRCS, will be presented, and there will be an opportunity to submit questions and comments at the end of the presentation. The Settingdown Creek watershed is located in northern Forsyth County, Georgia. The creek is a tributary of the Etowah River, which flows into the Coosa River near Rome, Georgia. The watershed contains over 34,000 acres of drainage area. And the original watershed work plan, which was prepared in the early 1950s, provided for the construction of 15 floodwater retarding structures, which are known as the Settingdown Creek dams. This slide presents a watershed delineation of Settingdown Creek. The delineation begins at the confluence of the Settingdown Creek and the Etowah River. For perspective, please note the location of US 19 Georgia 400 near the right or east side of the slide. Georgia 400 crosses the upstream portions of the Settingdown Creek watershed. Also, please note the locations of Keith Bridge Road, Georgia 306, Canton Highway, Georgia 20, and Matt Highway, Georgia 369, and as well as Georgia Highway 9, which is Dahlonega Highway, with their relation to the watershed. This slide presents the same delineation of the watershed overlain on aerial photography from the early 1960s. This would have been the condition of the watershed shortly after the dams were constructed along Settingdown Creek. As part of the preparation of the supplemental watershed plan, there were several focal points of analysis and study. These included consideration of upstream areas with regard to flooding and the need for additional storage capacity in the lakes, downstream areas with regard to flooding and potential breach zones were the dam to fail in a catastrophic manner, and evaluation of the hydraulic capacity of the existing spillway outlet works, how the dam and spillway systems perform during specific storm events, an analysis of the economic and social benefits provided by the dam, as well as an assessment of the environmental and cultural resources located within the vicinity of the dam. Once again, here's a map of the Settingdown Creek watershed. There are currently 6 dams within the watershed that are part of the planning process. Please note that the location of Settingdown Creek Dam number 6 is located near the upstream end of the watershed. Settingdown 6 is a dam that meets Georgia Safe Dams program criteria to be considered a Category 1 or high hazard potential dam. This means that failure or improper operation of the dam would likely result in the loss of human life. The dam requires an operating permit from the Safe Dams program. Prior assessments of the dam indicated that the dam does not comply with current SDP rules and requirements. The dam is not exempt from SDP rules and requirements. One purpose of the Supplemental Watershed Planning Study is to determine if federal assistance will be available to bring the dam into compliance with current dam safety requirements. And the Georgia Safe Dams Program is aware of this dam, its classification or pending classification as a high hazard dam, and that the dam is being studied by the planning team. Original design features of the dam include that it was not originally designed as a high hazard dam. The purpose of the dam is flood mitigation, and an anticipated secondary purpose of the dam is sediment accumulation and storage. The dam has a reinforced concrete principal spillway riser structure and nearly horizontal pipe or conduit that conveys water from the lake on the upstream side of the dam to the outlet channel at the downstream side of the dam. The dam also has a vegetated earthen auxiliary or emergency spillway constructed in the right abutment of the dam in order to pass flows associated with low frequency, high intensity storm events. Here's the watershed map once again with the location of Settingdown Creek, number 6, highlighted in yellow. You can note that it is the watershed is bisected by Georgia 400. The dam is located east of Hopewell Road and west of Georgia 400. It was constructed in 1957 and is on the order of 63 years old. The dam appears on the National Inventory of Dams and has a height of about 33 feet. That is a surveyed height. The drainage area is approximately 560 acres or 9/10 of a square mile. And the design total storage capacity of the impoundment is 360 acre feet. This slide shows the location of the dam on a 1963 aerial photo. Please note the land uses around the dam shortly after it was constructed in comparison with more recent aerial photography noting the location of the dam. Obviously, there's been some development in the vicinity of the dam along Georgia 400 and in downstream areas. This slide presents a limited topographic survey of the dam that was performed as part of the planning study. The survey is overlain on an aerial photo taken shortly after the dam was cleared during the summer of 2020. Please note the location of the principal spillway system near the left end of the dam. There is a gray rectangle in the lake. That is the principal spillway riser structure. The alignment of the principal spillway is indicated by the blue line running in a south to north direction. The earthen or vegetated auxiliary spillway is located at the right end of the dam. This slide shows a site map with topographic contours for the dam. Note the locations of the principal spillway, riser, and conduit near the left end between stations 400 and 500, and the location of the auxiliary spillway between stations 1400 and 1500 along the center line of the dam. Wetlands that were identified as part of the environmental assessment are also delineated and indicated on this site plan. Wetlands are located in the inlet channel of the auxiliary spillway, as well as in the floodplain areas beyond the downstream toe of the dam. This photograph was taken from the crest of the dam, approximately midway between the principal spillway and auxiliary spillway. As you can see, the location of the riser structure, crest of dam, and upstream slope are indicated in this photograph. This photograph was taken at the downstream toe of the dam near the outlet of the principal spillway conduit. The downstream slope is to the right of this photo. The principal spillway conduit is apparent, and the water from the conduit is discharging into a plunge pool immediately downstream of the conduit. An environmental survey was performed to support the environmental assessment efforts for this dam. The aquatic resource survey, shown at the left-hand side of this slide, indicates the survey area of the environmental survey, the location of invasive species, which have primarily and predominantly been identified as Chinese privet, as well as the locations of streams, wetlands, and open water within the project survey area. No protected species were found during the survey. In addition to the environmental assessment, a Phase 1 cultural resources survey was performed for the dam. This survey included fieldwork and a literature review of the project area. The cultural resource survey coverage map is shown at the left-hand side of the slide and indicates the location of survey transects and shovel tests performed by the cultural resources team. No archaeological resources were recorded as part of the Phase 1 survey. The dam, being older than 50 years, is eligible for consideration on the National Registry of Historic Places, but its placement on the registry is not recommended. The dam is old, however, it is not unique, and there are no exceptional feats of engineering associated with it that would give it credence to be included on the registry, in the opinion of the cultural resources team. There are hundreds of dams, such as Settingdown Creek 6, located in Georgia and across the country, but that doesn't necessarily mean that their historicity is unique or merits eligibility for the registry. As part of the evaluation of the dam and downstream areas, a dam breach analysis was performed, and downstream hazards or potential hazards were identified. This map shows the limits of inundation associated with a hypothetical sunny day breach of the dam, and the locations of potentially impacted structures are also identified on this map. The location of Settingdown Creek Dam number 6 is at the right-hand side or east side of the map. In addition to the breach analysis, downstream flood analysis was performed for the 2 through 500 year storm events. This included consideration of other dams and areas within the watershed upstream of the limit of study shown at the left end of the map or creek. The analysis point for the downstream flooding was terminated at a location just downstream of John Burris Road in northern Forsyth County. The map indicates the extents of 100-year and 500-year flooding downstream of the dam, as well as structures that would be potentially impacted by flood waters. As part of the storm routing performed upstream of the dam, a upstream flood limits map has been developed to identify any structures upstream of the dam that might be impacted by rising waters stored by the dam and spillway system. The map shows the extents of the normal pool elevation along with the elevations associated with the auxiliary spillway control section and the dam crest. Additionally, the extents of the 100-year and 500-year storms are shown in red and orange respectively, and the maximum water surface elevations associated with the Georgia Safe Dams Program design storm and the NRCS freeboard hydrograph storm, which is 100% of the PMP, are also indicated. As you can see, there are no structures of consequence that are flooded by the 100-year or 500-year storm. However, a commercial interest, apparently a cell phone tower foundation, would have a limited amount on the order of 1/10 of a foot of water inundating it in the event of the NRCS freeboard hydrograph storm event, which is on the order of 30 inches of rain, 32 inches of rain in 6 hours. A review of existing deficiencies with the dam. As noted previously, previous dam assessments and studies indicated that the dam and spillway system may not be capable of passing Georgia Safe Dams Program criteria. So just keep that in mind as we go through this list of deficiencies. The dam was recently cleared during the summer of 2020. An underwater inspection of the riser structure concluded that portions of the slide gate assembly are worn and or covered in marine growth, so some attention may be needed to improve the condition of the slide gate. The gate is covered by accumulated sediment, and portions of the concrete on the riser structure are cracked or spalled and may need some attention. A closed circuit television inspection of the interior of the principal spillway conduit was performed and reviewed by the planning team. The interior of the pipe and joints are in acceptable condition. Updated modeling for the dam indicates that the dam in its current state is capable of safely storing and passing the Safe Dams Program design storm event with adequate freeboard. This design storm event is 1/3 of the probable maximum precipitation and would be on the order of 10 to 11 inches of rain over a 6-hour period. Just to reiterate, the dam is capable of passing this design storm with adequate freeboard and without the auxiliary spillway breaching. With regard to NRCS storm criteria, the auxiliary spillway engages prior to the PSH storm event, which is a limiting storm for NRCS requirements. The principal spillway conduit is not capable of meeting PSH drawdown requirements. The auxiliary spillway control section elevation is 3.6 feet lower than is required by NRCS standards. The dam overtops by 1 foot during the NRCS design storm event, and the auxiliary spillway breaches during the NRCS design storm event. As a result of some of the noted deficiencies or maintenance items that need to be addressed, 3 levels of rehabilitation alternatives have been shortlisted for this dam. The first would be a no action alternative. This assumes that the dam would be rehabilitated or improved to meet Georgia Safe Dams Program criteria for a high hazard dam, and that no federal funding would be available or necessary to meet these criteria. The no action alternative could consist of a permanent breach of the dam or rehabilitation to state criteria. This would be based on which of the 2 options, either the breaching or the state rehabilitation, are more cost effective to the project sponsors. A decommissioning alternative is required to be considered as part of the planning process. This would be removal of the entire earthen embankment and stabilization of the lake and channel through the dam. It also requires consideration of increased flooding to downstream interests. The final alternative that will be discussed today is the future with federal investment alternative, which would be a full NRCS rehabilitation to meet criteria outlined by NRCS regulations and guidelines. This would involve improvements to the embankment, improvements involving removal and replacement of the principal spillway, and likely the decommissioning of the earthen auxiliary spillway and a construction of a structural spillway to pass the larger storm events. During the development of the NRCS rehabilitation alternatives, consideration was given to upstream non-flood control ponds and uncertainties associated with rainfall depths associated with climate change. The no action alternative for this dam would involve generally maintenance items. This would include leveling the crest of the dam to a consistent elevation where there are low spots and regrading the upstream and downstream slopes to 3-to-1 in areas where the slope is steeper. It would also involve the construction of a riprap lined wave berm along the upstream shoreline to protect against wave erosion in the lake. The principal spillway rehabilitation would involve design and construction of a riprap lined plunge pool at the downstream end of the conduit. For lack of a better term, refreshing the existing plunge pool and confirming that the dimensions are adequate for flows from the pipe. And based on the current configuration of the auxiliary spillway, there are no structural measures needed to address any concerns with the auxiliary spillway. There are some obstructions in the form of woody vegetation in the inlet channel that the project or the planning team would recommend being removed. Here's a site plan that indicates the no action alternative and the extents of it. The existing riser structure could be left in service. Some consideration should be given to excavating the base of the riser structure to free it from accumulated sediment so that the low-level gate system can be evaluated and improved as needed in the event that the lake needs to be lowered for maintenance purposes in the future. The location of the plunge pool is also indicated downstream of the dam at the left end of the dam. Regrading of the slopes to provide uniform crest and 3-to-1 slopes is recommended. Obviously, revegetation of the dam with permanent turf grass is recommended, and the construction of a riprap lined wave berm for wave protection on the upstream slope is also shown. At the right end of the dam, where the auxiliary spillway is located, the auxiliary spillway inlet channel for the width of the spillway is recommended to be cleared of obstructions so that in the event that storms increase water levels in the lake, that flows can make their way into the inlet channel and over the control section without obstruction. Here's a profile view of the proposed improvements. It appears that the dam is being raised in this view. However, we just note that there are some discrepancies between some of the GIS topography that was used and the field run topographic ground shots that were performed on the crest of the dam. In general, the crest of the dam does not need to be raised. However, there are some irregularities in the crest elevation that we would recommend being smoothed out to provide a uniform crest elevation across the dam. The decommissioning alternative was also considered as part of the planning process. This would involve permanently draining the lake by removing the entire dam and reconnecting the floodplain, the original floodplain, beneath the dam footprint. This would also involve stabilization of the lake bed with permanent vegetation and stabilization of the primary channel through the footprint of the old dam with riprap. While decommissioning of the structure would improve flooding upstream of the dam, the downstream flood benefits would be lost. And the planning team has also evaluated and quantified the downstream benefits currently provided by the dam, as well as the loss of those benefits if the dam were to be removed. Here's a site plan that indicates the effort to remove the existing dam. As you can see, contour lines are shown at the left and right ends of the dam, and in between those contour lines, the material that creates the embankment would be removed. The floodplain would be reconnected to the original line and grade prior to the construction of the dam, and the channel where the principal spillway existed would be lined with riprap, since that would be the primary location of flow permanently. The lake would no longer impound a permanent pool and would be stabilized with permanent vegetation and would likely revert to a wetland area in this scenario. Here are a couple of photographs of what a decommissioning alternative would look like. As you can see, the slopes of this dam, actually the main portion of the embankment has been removed. The excavation slope has been laid back to a manageable slope on the order of 3:1 and revegetated. And these photos also indicate the location of stone armoring through the primary flow channel that would result after the dam is removed. The final alternative that we'll discuss in this third public meeting is the future with federal investment alternative, which would involve a full rehabilitation of the dam to meet NRCS standards. This would involve raising the crest of the dam to the current maximum water surface elevation associated with the design storm event, regrading the upstream and downstream slopes, constructing the riprap-lined wave berm, and decommissioning or closing off the existing auxiliary spillway that is not capable of passing 100% of the PMP without breaching. The principal spillway would be removed and replaced with a new riser structure. The existing conduit could be reutilized, but would require extension, and a plunge pool would also be constructed just beyond the location of the existing discharge point of the pipe. A relatively large structural spillway would be required for this dam to allow it to pass the design storm event. The planning team is proposing a broad-crested roller compacted concrete stepped spillway to perform this function. The spillway would be on the order of 160 feet wide and would have a step height of 1 foot. The spillway could be constructed over the earthen embankment, and consideration would be given to providing access to both sides of the dam and spillway from the dam crest. The spillway would include reinforced concrete sidewalls and a stilling basin and riprap-lined apron at the downstream toe to dissipate energy associated with high flow storm events. The site map shown on this slide indicates what this option would look like. Note that the principal spillway riser structure and plunge pool would be replaced and slightly relocated. The wave berm and riprap is also shown along the upstream or bottom side of the dam in this view. The auxiliary spillway at the right end of the dam would be decommissioned by filling with compacted earth fill up to the crest of dam, the proposed crest of dam elevation. And the location of the RCC spillway is shown at the center of the view. The spillway would be stepped on a 3:1 slope down to the base of the dam or floodplain area, and flows through over the steps would discharge onto the riprap apron the RCC spillway, stilling basin, and riprap apron. Here's a profile view of what the step spillway would look like. You can see the top of the proposed sidewalls, the location of the steps, the location of the wave berm upstream of the spillway, and the location of the riprap apron downstream of the spillway. We've provided a couple of photos with examples of what these RCC spillways would look like. You can see here in this photo that there's an opportunity in some cases to cover portions of the RCC with soil and grass after their construction. These spillways would not flow on a regular basis. They would only engage during relatively infrequent storm events on the order of the 100-year and 500-year storm event. Here's another example of a spillway, an RCC spillway that the steps have also been covered with soil and grass since those spillways, as was discussed just previously, they will not flow on a regular basis. And here's one more option or view. This photograph would be most likely the most similar to the option that would be required for Settingdown 6. So as a result of the planning study and discussions with the project sponsors and representatives of the NRCS, the planning team is putting forward the locally preferred alternative for this dam as the future without federal investment or no action alternative for the dam. The dam currently meets hydraulic requirements for the Georgia Safe Dams program, and is recommending that some maintenance issues be addressed and improved for the dam. That includes leveling the crest, regrading the slopes to a uniform 3-to-1, installing the riprap lined wave berm along the upstream shoreline to help with wave erosion, extending the principal spillway conduit slightly downstream and constructing a riprap lined plunge pool at the downstream end, and no structural modifications to the auxiliary spillway. We do recommend that the inlet channel of the spillway be cleared of vegetative obstructions so that flows can enter the auxiliary spillway without obstruction. As part of the planning process, the planning team welcomes public participation in the form of questions and comments. Project stakeholders are invited to submit questions and comments regarding the plan development and the presented rehabilitation and locally preferred alternatives. Questions, concerns, and comments may be submitted using the Google form at the web address provided below. Please note that the link shown in this recording is not clickable. We do intend to provide a clickable link in the comments section below the YouTube screen for this particular presentation. If not, the address shown, HTTPS address shown on the screen, can be typed into a web search engine or Google Chrome, Internet Explorer address bar. We will accept questions and comments associated with this third public meeting through Monday, July the 19th, 2021. And after receipt of any questions and comments, those will be addressed in a subsequent presentation or document that is distributed to project stakeholders. Once again, we would like to thank you for your interest in the project and your participation in the planning process. Please, we encourage you to submit your questions and comments, and we thank you once again for your time in reviewing this presentation.